Hello everyone and welcome to Mathics. In this video we're going to do AMC Australia and it's going to be year 2021 intermediate level. Okay, I'm going to give full explanation from question 1 all the way to question 30. So leave a like button before we start. Okay, so the first thing, question 1, let's start. This star over here has 10 edges and each edge is 2, and we know the meaning of perimeter. Perimeter is like how long the star is all the way here, and we have 10 of these obviously. Okay, so it's going to be 10 times 2, 20. Okay, let's focus on the second question now. Okay, what is the value of this? This is going to be 1,800. Okay. Plus 20 minus 18. This would be all of it plus 18. So obviously it will be C. Okay. So question 3. Okay. What is the value of A in the diagram? Obviously it's an angle. And we know the internal angle of this will be 360. So we have two 90s here. So it's going to be 360 equals two 90s. 90 plus 90 plus 145 plus A. Okay. So obviously A would be 35. Okay. Okay, what is 50% more than 1 over 2? Well, 50%, okay, I'm going to write it in fraction form. And if we simplify it, dividing both of them by 50, we'll get 1 over 2. Okay, so the question is a little ambiguous because if you write it like this, 1 over 2 plus 1 over 2, it would be 1, but fortunately, this is not one of the options. And I don't think the question meant this, but fortunately, it's not here. So here what it says 50% of 1 over 2. So it's going to be 1 over 2 plus 50%, okay, of 1 over 2. Okay. So this side, 50% is 1 over 2 multiplied by 1 over 2. So it will be 1 over 2 plus 1 over 4. Obviously, it's going to be 3 over 4. So this one. Okay, question 5. Okay, not a lot of numbers, so I'm just going to add them. 16, 21, 24, 25. Okay, these two 10. These two 10, 20, 30. 5 over 6. Okay. It's very easy, aren't they? But the questions get more challenging, right? So the last question, 25 to 30, very, very challenging. Okay, A, B, C, D. The shaded area is 16. What is the length of the side of the square? So obviously we have 4 of these. So the whole thing will be 4 of 64. Sorry. 4 of 16, which equals 64. So the area is 64. So again, if the area is 64, that means each side of the square was 8. We multiplied it, we got 64. Okay, so it will be 8. Okay. On the number line, which number is halfway between 2 to the second power 4? Okay, so this one will be 100. Okay, and then You see, this is going to be, for example, a number line, something like this. This is 0. For example, this is 1,000. And then we'll go, this will be 10,000 here. Will be further away, but I don't have a space. So what is halfway between these two? Okay, so it's going to be average of these two numbers, but the options, looking at the options, they're not very close. Okay, so average of these, we know that 10,000 is going to be, half of it will be 5,000. So 5,000 and something, the only option is 5,000 and something is this one. Okay, you don't have to do it all. After all, it's a test. So we need to be quick. Question 8 is a little better than the previous questions. This might be challenging. Okay, so we have, to feed a horse, Kim mixes 3 bags of oats with 1 bag containing 20%, I'm not sure, lecrine, I don't know, and 80% oats. So if all the bags have the same volume, what percentage of the combined feed mixture is lecrine? So first of all, I don't think this word is very accurate. They should have written mass, right? Because after all, we hear about the mass in these combinations. But anyway, so we have, let me do something here. We'll have 3 full bags, okay? And all of these are oats, okay? But the last one, okay, 20% of the last one is not oat. It's just that L little thing, right? It's just going to be, but it's going to be 20% of it, okay? So this would be 20%. Okay, how do I know it's this much? 20%, I'll write it in a fraction form. Dividing both of them together is 1/5. Okay, so this much is L, lustrine, green, I don't know. So this one. Now, what is the full fraction of this, right? If you like, you could draw, right? That's going to be simple. Each one will be 5. Okay, 5, 5, 5, 5, 5, 5, 5. Okay, so we'll have 20 of them. Okay, 20, okay, the smaller units, one of them will be this, okay? So 1/20th of everything will be L, like that. So if we want the percentage, so this will go, has to be 100, it will be 5, it will be 5%, okay? So another way over here, it would be, okay, 1/5, which was this number we start with, 1/5 of one of the boxes is not oat, is that lecrine thing. And we have 4 of these, we could divide it by 4, which would be, again, which would be 1/5 multiplied by 1/4, which would be 1/20. Okay, and 1/20, we have it here, is equals 5%. So either way that you are more comfortable with, it's going to be B, 5%. Okay, let's continue with question 9. I have a solid, let me make this black. I have a solid block of wood in shape of a cylinder, and the top and bottom faces meet the curved side at right angles. Suppose that I slide the cylinder along a plane to create 2 smaller blocks. So which of the following could not be the shape of the resulting faces created by the slides? So if you're anything like me, you don't like these types of questions because they require you to imagine stuff. Okay. But let's see. This one is not very difficult. So if we cut the plane, right, I will have the plane. We cut it like this. Okay. So what shape do we create? Obviously, this would be, okay, a rectangle. So this one is out. Remember, which shape could not be made? That was the easiest one. And obviously, if we cut it from here, right? I didn't draw something well, but it would be a circle, right? So if we cut it like this in this direction, we're going to have a circle like this. Okay, we cut it with a plane this way. I hope you can imagine it. So this one obviously will be out. So let's go. How can we get anything else? What if, okay, I'll go, the plane goes with an angle like this. Okay, so we cut it, but this way. Okay, then the resulting shape will be something like this. It would be a circle, but not quite. It's an oval. Okay, so this would be the third shape. So from here, it's easy which one looks weirder, right? So now imagine I will cut everything like this. So what do I get if I cut things with this plane like this? Okay. See, when I have this side, okay, let me go ahead. So this, okay, will be a straight line. It will create this side, okay? But these edges, right, this part, when we cut it like this, it will be this part, okay? So this one, we made it. The one we cannot make was a triangle. So it was also easy to guess because to get a triangle, how are you going to cut that? Okay, so let's go question 10. Yeah, oh, let me make this black. The odd-timer self-cycling laps around his suburb. After 5 laps, her stopwatch indicated a time of 16 minutes and 15 seconds. What was... Okay, so basically we want the average. Okay, so not very difficult. We're going to have 18 minutes and plus 15 seconds. And because it's an average, we're going to divide it by 5. Okay. So I think the best way is to write this as 15 minutes plus 3 minutes. Okay. So it'll be 15 minutes divided by 5 plus 3 minutes is 180 seconds plus 15 seconds. This would be, the first one will be 3 minutes. Okay. So that would be 195 divided by 5, which would be 39. So 3 minutes, this is 39 seconds. Okay, question 11. So now that we are question 11, we could expect the question to be just slightly more challenging. Okay. I have 4 consecutive odd numbers. The largest is 1 less than twice the smallest. Which of the following is the largest of the 4 numbers? If you are a non-native speaker, you will have problem with this word. Consecutive means they are in counting order. So for example, because it says consecutive odd numbers, it'll be something like, for example, 5, 7, 9. So if I write here 10, of course it would be even number, not accepted. If I miss one, not write 11 instead of 11, if I write 13, not going to work because it's not consecutive. Right? I missed one. So the worst thing you could do in a test is just try to solve the problem. Don't do it, right? Guess the value of it. So the largest one is less than twice the smallest one. So I'll go with 13, the middle one. So I'll have, what is the largest of them? 13, 11, 9, and 7. So we have 4 consecutive odd numbers. The largest one is 13. Which of the following, okay, now the largest one, 13, is one less than twice the smallest. So twice the smallest number is 14. And 13 is, okay, obviously, so 7, double of that, twice of this is 14, okay, and 13. So now look, the largest one, 13, is 1 less than 14, right? And 14 is twice of the smallest number. So we were lucky. So the first guess, I went with the middle so that I could decide if the answer would be larger or smaller. So we got lucky. So the first guess is the answer. Okay, so let's do the next question. On a compact disc, a CD, right? Uncompressed music data is stored as disk samples for each second of music, where each sample requires 4 bytes of data. Which of the following is closest to the number of bytes required to store 5 millions of music on the disk? Question 11. I have 4 consecutive odd numbers. The meaning of consecutive is in counting order. So for example, 2, 3, 4 are consecutive, okay, because that's how we just count. But if I write 2, 4, 5, I missed 3. It's not consecutive, okay? And here, all of them have to be odd numbers. So for example, 3, 5, 7, 9, that's consecutive odd numbers. Okay, the largest is 1 less than twice the smallest. Which of the following is the largest of the 4 numbers? Okay, the worst thing you could do is try to solve this equation. Why? Because it's a test, right? So all you have to do is guess. I will start with the middle one, okay, so that I could try something bigger or smaller if it doesn't work. So if 13 is the largest one, and we need 4 of this, I'll write it like this. Now, the largest one is 1 less than twice the smallest. The smallest is 7. Twice the smallest is 14. And 13 is exactly 1 smallest than 14. So I got lucky. Easy peasy. So let's go and do the next question. Question 12 it would be. Okay. So on a compact disc, a CD, uncompressed music data is stored as blah 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 samples for each second of music. Okay, so 1 second will have 440 samples, right? I'm gonna just write Sam, too lazy. Where each sample requires 4 bytes of data. So 1 SAM, it becomes like 4 bytes of data, okay, which is 4 bytes. So which of the following is closest, important word, to the number of bytes required to store 5 minutes of music on the disk? So closest means we're going to round it up, but look at the options. They're too far, right? So we could round it like just so we have a lot of safety. So I'm going to go, instead of this, round it to 50,000. Okay. So now we want 5 minutes, right? 5 minutes. Okay, this would be multiplied by 60, 300 seconds, right? Okay. And each second was this number, which we have it, this many samples, 5, and it got 4 zeros. So I'm going to write it like this, easier. And each one had 4. So basically, that's what we're going to do. So let's see here. We're going to have, I'm just going to multiply a 3 by a 5 by a 4. It's going to be 60. And then we had 2 zeros and 4 zeros here. That's going to be another 6 zeros. Okay. So which one are we closest to? 50 mils. And remember, we round this up. So the real answer should be a little smaller than 60 million. So that makes sense. So the answer would be D. So the questions are slowly but surely getting more challenging. Okay, so question 13, however, is not very difficult. Okay, so we know that this angle over here, this orange angle, is an exterior angle, which equals to these two internal opposite angles. So the green ones together are the same as the orange one. And this one we have it, x. This one we have it. This one we don't. But this one is easy to find. We know that this 3x plus this question mark is 180. So I'm going to write it like this. 3x plus this missing angle is going to be 180. So it would be, the question mark will be 180 minus 3x. Okay. So we got this missing angle over here. Okay. So this one plus this one will be the orange one. The green ones, I'm going to write them green. So 180 minus 3x, we found it. Plus this x over here, okay, would be, okay, it would be this one, x plus 30. So all we really need to do is solve this equation for x, and then we get our answer. So let's see it here. This x was, so these two will be negative 2x. Okay. Going to this side, right-hand side will be 3x. And it would be 180 minus 30, 150. So what is the value of x? 50. There we go. So let's move on to question 14. Again, you don't want to solve each question you see, right? You just want to eliminate the options that wouldn't work, right? So what is the equation of the line passing through 0, 0.0? Okay, of course, this one. That bisects the square in the diagram. Okay, so let's focus on this point together, right? This one. So this is on x-axis, right? And this would be on y-axis. And we're talking about this point. So here, when x is 1 for this point, what do you think is the value of y over here? I think it makes sense. In the picture, you can see it's definitely y is going to be something smaller than 1 over 2. Do you agree? I'm going to just write it like this. Something smaller than 1 over 2. Now let's try the points. This equation, if I give it 1, y would be 3. But y is supposed to be something smaller than 1 over 2. Out. X is 1. This would be 2. Out. Okay. X is 1 for this one, b. Y would be exactly 1 over 2. But we could see it's smaller than 1 over 2. So out. So we have eliminated 3 options using the first point. Good. Now let's focus on the second point. When x is 2, okay, do you agree the value of y is actually more than a half? If x is 2, this one, okay, is something more than 1 over 2. I'm going to write it like this. It's not, I don't think it's right, but I'm going to write it like this anyway. So if x is 2, right, let's give it to this equation. If x is 2, the value of y would be 2 over 4, which is going to be 1 over 2. But we said it's going to be more. So this one is also out. Let's check this one. If x is 2 for this equation, y would be 2 over 3. That's the only option that will give something more than 1 over 2. So we'll go with A. Okay, question 15. Okay, I'm going to do some drawing for question 15. A standard dice numbered 1 to 6 with opposite sides adding to 7 is placed on a 2 by 2 square as shown. Okay. So when it says 7, so for example, 3 and 4 are opposites. 6 and 1, 2 and 5 are opposites. The dice is rolled over, one edge onto each of the 4 squares in turn. So here it says that it's going here, then we're going to go here, then we're going to go here, and then we're going to back on the original square. But what does the question want? What side of the dice is now facing upwards? Okay, so let's just see. Okay, when we go here, right? Let's do a little drawing here. Okay, you see, do you agree? This will be 1. When we roll here, this would be our 1. What about picture? Okay. And when we do it here, the number over here was 3. So 3 would be on top. This 5 wouldn't change. Do you agree? Okay. So now we want to move over like this in this angle. So let's change the color. So when we do so, okay, when we rotate like this, the value of 1 wouldn't change. This 3 will be here. What was opposite of 5 will be on top, 2. Okay, so let's do it here as well. Try to see if I can make something larger. Okay. So again, we're going to roll this way. 3 wouldn't change. 2 will go here, 1 will be on top. Okay. So, what would be here? What is bottom here? Right? It's a 5. Okay, we rotate like that. Okay, the 5 will show right over here. Okay, so we don't even actually need it because when we are going this way now, see, we just want the one that is upright, the one on top. Okay, obviously it would be this 3. Roll like this. So 3 will be right over here. 5 wouldn't change. Okay, so the upright one, 3. There you go. So let's go and continue with question 16. Okay. So I think from here, the questions are challenging. So I try to explain more. Okay. The two spinners shown correspond at the numbers that the arrows point to when they stop or recorded. For example, the numbers here are 3 and 6. What is the probability that the sum of the two numbers is even? So for example, now is this even? We got a 3 and we got a 6. So when we add them, it's an odd number. Okay. But we want even numbers. Okay. So let's just start. If this is 3, the first one, if this is 3 for the first one. The second one, should it be even or odd? Okay, it should definitely be odd because 3 plus 5 is 8, right? Odd plus odd, even. Okay, now what is the chance to get 3 and a 5? The chance for this, because the area is larger, is 1 over 2. The chance of getting this 5 over here is 1 over 3. So we just have to multiply these two. That would be 1 over 6. Okay, but that's not the only option, right? We need to find the other possibilities as well. What if we get the 1? Again, 1 and 5. So I'm going to write it here. What's the chance to get 1 and 5? To get 1, the chance is 1 over 4. To get 5, 1 over 3. So it will be 1 over 12. Okay, to get 1 and 5. So let's go. Is there more options? Yes. So what if we get a 2? Okay, but if we get 2, we have a large chance to get another even number, so the sum will be even. So the purple one, the chance of getting a 2 is 1 over 4. The chance of getting 4 and 6 over here is 2 over 3. Okay, this would be 2 over 12, which is the same as 1 over 6. So you see, to get an even number, all of them are possible, right? So we need to add these possibilities together, right? So 1 over 12, 1 over 6 plus 1 over 6. it would be 5 over 12. Okay, I just added them, right? Okay. Let's go question 17. The area of the shaded region is given by, see, this question looks scary, right? But it's very easy. If you're the type who is scared by a question, you lose an easy peasy question. See, the shaded area, if you look at it, wow, how am I going to answer? Oh, so complex. But, well, the shaded area is going to be the area of the large rectangle minus, you see, minus this and minus this one as well. Okay. And again, minus this one and minus this one. Okay. Not very difficult. So let's go and write them. So the large one is going to be a plus b multiplied by a plus c. A plus b multiplied by a plus c. Good. Not very difficult. So these two, this one is going to be BC, half of BC, because it's going to be BC over 2. This one also BC over 2. It's a triangle, that's why we're dividing by 2, obviously. And this one, A squared over 2, A squared over 2. So let's write them here. These together will be A squared. Okay, these we're adding these two. We have 2 half of BCs together. They make 1 BC. Now, what is this one? It would be A squared, A times A. Okay, and then A times C. Okay, and A times B. I'm going to go, okay, let's write it all. So AA, AC plus AB plus CB. Okay, so all we have to do is minus these, right? So remember, I'm not cleaning the minus, the orange one, right? We just have to minus them. Minus this, okay? So we know that BC and CB are multiplied, like 3 times 4 is the same as 4 times 3, so they are the same. Okay, this one, these two cancel. A squared canceled by this. What is left? AC plus AB. Not very difficult, was it? Okay. Okay, question 18. Again, another easy question. If you just try to guess the value, so if k and n are positive integers and we have this equation, then the smallest possible value for k is, okay, we want to minimize k. Okay, what is the smallest value for n? It cannot be 0 or negative, so n would be 1. Then it will be 10 plus k, okay, equals, and the square roots of this is supposed to be k again. Okay, so the only number that could work here, okay, we know that it's going to be 16 would be the smallest number. And if it's a 16, then k has to be 6, but this would be 4. So it's not going to work. Okay. And how about n being 2? Okay, if n is 2, this thing will have to be 20, and we know that 25 has a square. So if k is 5, the square root of 25 will make, okay, 5 again. So k could be 5, so these two are out. 6 is out, 10 is out. So let's try a few more. If this is 3, well, 36 will work if k is 6. But this one will get larger and larger, but it's 6. So the next one, let's see, even if it's 49, then the value of k becomes 7. It's growing. Okay, so there's no way that we could come up with something that would be smaller than 5 that we already got. So the smallest value for k is coming from 25 being squared, creating 5 again. So k would be 5. Okay, the next one. 2 squares are drawn as shown. The smallest square covers 1/8 of the larger square. So one possible mistake is that to write this, okay, 1/8. So this area is 1. The larger square, all of this will be 8. Is that correct? Well, no, that's wrong. Okay. What is correct is to write it as 1. This would be 1. And this would be 7. Why? Because this area, right, of all the larger square. So the largest square, the area of the square will be 8. The shared area would be 1. Okay, so that's going to be for this shape. And the larger square, the big one, covers 2/9 of the smaller one. Again, for the same reason. But here, we have to call this 2. So I'm going to call this 2, multiply this by 2. And then multiply this by 2 as well. So this would be 14. Again, we're keeping the same ratio. So if you write again 9 here, it's wrong. You have to write 7. This would be, all of this is 7. Then plus 2, the square will be 9. Okay, now easy peasy. So what does the question want? What is the ratio of the side lengths of the larger square to the side lengths of the smaller square? So the large one, this was 14, plus 2 is 16. 4 times 4 is 16. 7 plus 2 is 9, so this is 3 times 3. So the ratio of them, okay, 4:3. Okay, let's go. Okay, and let me see if I can make this a little larger. Okay, so we'll have 6 identical darts, okay, fit inside a regular hexagon as shown. Each dart has 3 interior angles of 30 and 1 of 270. Okay, what fraction of the larger hexagon is shaded? Okay, let's see here. It's saying this is 30, this is 30, this is 30. And this large one is 270. Because that large one is 270, this is a right angle, okay? So you could also see that this one and this large one are actually similar, okay? You could also go and prove it. So it says this is 30, okay? So this one is also 30, okay? Okay, let's go and do this question 20 together. 6 identical darts fit inside a regular hexagon as shown. Each dart has 3 interior angles of 30 Okay, these three are 30. And the one, 270 would be from here all the way to here. What fraction of the large hexagon is shaded? Okay, because this one is 270, okay, this would be a right angle, okay? And even in the picture, we could see that the two triangles, so if I call this one highlighted red, okay, this one will be 30, okay, not very clear. This one would be a right angle. This would be 60, right? So the same thing is true for the smaller one, okay? This is going to be 60. This would also be 30, okay? So we know that these two are similar, okay? So because they are similar, okay, we just need to find the ratio of the side lengths. So this one, I'm going to call this A, right? If this is A would be the hypotenuse for this smaller one. So we're going to have one right triangle with hypotenuse becoming A. Now this one is A. What if we are in this larger triangle? And remember, this is 30. We know that the side that is in front of 30 degrees, okay, is half of the hypotenuse. So from here to here will be 2A. If you know sine and cosine, we know that 2A sine 30 would also be 1 over 2. 2A times 1 over 2 is A. Okay, so now in this triangle, right, the large one, the hypotenuse would be 2A, right? So we'll have this one. The large one would be hypotenuse. And we know that these two are similar. They have 90, 30, and 60 degrees as angles. So what is the ratio of the areas? The ratio of the area would be, because they are dissimilar, okay, it would be the ratio of the sides squared, right? So 2A divided by A is 2. It's going to be 2 squared. It's going to be 4. That means the large one is 4 times the smaller one. So that means if I go and call this a small area 1, it's a ratio question. Okay, then the big one was 4. So, and from here to here would be a 3. Isn't it right? Together it become 4. So the area of this is 4. The area of this is 1. This is 3. So let's go and highlight. This is also 3. So everything that is shaded will be 3, 3, 3. And we have 6 of it. So the shaded area will be 6 times 3. Now let's go find the total area, okay? So remember, I said that this is, all of this is 4, okay? So all of this will be 2 of this 8. So 2 8s, 3 8s, 4 8s, 5 8s, and 6 8s. So it will be 48. So it would be, let's simplify, 1, 8. The ratio is 3 over 8. There you go. Okay, let's continue with question 21. Question 21 to 25, of course, will be more challenging and they will take more time, okay? So let's read the question together. we want to place numbers into each of the blank squares, okay, in the diagram so that each of the numbers we place in the is the average of those in the squares directly connected to it. Okay, so for example, this is empty space. If I write the number like x here, this would be average of 1, 2, and this number that is here. Okay, so that's what it means. What does the question want? It wants what number should we put in the middle of the square. Basically, it's going to be this. What number will be over here? What number should you put in the middle of the square of the top row? So let's go and do this. I'm going to call this one x. Then this one, the top one, will be x plus 3 over 3. This one will be x plus 2 plus 3, which is 5, because it's the average and we're going to divide it by 3. So it's going to be x plus 7 divided by 3. It's going to be x plus 4 plus 1, which is 5 over 3. Okay, so now this x is the average of all these 4 surrounding it. This one, this one, this one, this one. So that would give us one equation, and we're going to solve that equation. So let me write. It's going to be x is the same as, okay, all of these together and then divided by 4 because we got 4 terms. So it will be all of these together. I'm going to go straight, okay? So it will be, of course, over 3. It's going to be 4x. Okay, 4x because we have 4. 1, 2, 3, 4. And plus 3 plus 5 is 8. 15, 20. So it's going to be 4x plus 20. Divide over 3 over 4. Okay, this 3 is from, of course, these. This over 4 dividing by 4 is because of the average of the 4 terms. So I'm going to write this. This will become, x would become as the same as 4x plus 20 over 12. So it will be 8x would be 20. So x would be 5 dividing it by 2. So let's go. Am I right here? So 12x or 8x is 20. Dividing both of them by 4. So 2x would be 5. So value of x would be 5 over 2. Right? Yes. But the thing is, this is not good enough, okay? Because we want the value of this. So it will be, instead of x, I'll go 5 over 2 plus 3, and then dividing everything by a 3, okay? So what is this? It will become 11 over 2 divided by 3 would be 11 over 6. There you go, okay? So you see that these questions are not as easy as the starting questions. They're getting more difficult, more challenging, okay? So let's read this one. To set the timer on his microwave oven, Rick enters the digits of the hours, I can't read it, minutes and seconds in order from left to right. This is important. For example, entering this sets the timer. See, these two are seconds, these two are minutes, this one is hour. Okay, so if we have 408, okay, the first two will be, these two will be seconds, this 4 will be minutes. Okay. And now what happened? One day, Rick accidentally missed the last digit. And the timer finished 4 minutes and 42 seconds earlier than he was expecting. What was the missing digit? Okay, so let's practice with this, right? So if he wants to set it on this, it will be 4 minutes and 08. If he misses the last digit, he would only write 40. And because there's only 2 digits, both of them will be seconds. So it would become something like this. Okay, so the result will be 3 minutes. This would be 68 seconds, will be 3 minutes, 28 seconds. Okay. If he wanted to put it on this, but now let's see. This number is supposed to be 4 minutes. Now, what number should I write here so that when we minus it and subtract it, we'll get 4 and 42? What number? Okay, guess the value of, like, play around. If you come so far, definitely you will find the answer. Okay, so because we want this to be 4, so this has to be 5. Okay, so it'll be 5 and something. So, and then how to write the other 2 seconds? We know whatever I write, this is also 5. Okay. So this is supposed to be 4 and 42. Okay. So let's see. Let's try. It's up to us. For example, let's go if it's 5 and 50. So this would be 55. What number do I get if that's the size? If I minus these two, I'll get 4, which is a good thing. But I'll get 55 seconds, which is too much. So this is too large. Okay. So let's go with something else, right? We just have to play around and see what happens. You see, I'm gonna go with something like 53. Okay. So what if I write something like this? Okay, 35. Okay, it will be 53. Okay, so I know it because I've done it before. So now this 5 becomes 4. Okay, this becomes 95. Minus 53 is exactly 42. So there you go. He wanted to put it on 5 minutes and 35 seconds. So accidentally, he only wrote 53 seconds. And when we minused it, it finished 4 minutes, 44 seconds earlier. So what is the missing digit? Of course, the last one. Why is this the last one? Because it says we're going left to right. So the answer is 5. Okay, question 23 is extremely long, and I don't know why this is question 23. Let's go and do it. I built a large cube from units cube. Then I completely paint a number of faces of the large cube. When I dismantle the large cube, if you don't speak English, it's not your mother tongue, means just to open it piece by piece. I find that I have 288 unit cubes without any paint on them. How many faces of the large cube were painted? Okay. So these questions look very scary at first. Okay, but don't be scared. Let's start by an easy one. Like the easiest one is, well, of course, 1 by 1. You paint one side, everything is painted. The next one will be a 2 by 2, right? So it will have 4 unit cubes, okay? The next one will be a 3 by 3. Okay, we're going to analyze that's not a good picture. We're going to analyze this together. It's going to be 3 by 3. You see, each one will have 9 cubes, right? So let's see. How many, first of all, how many unit cubes are here? 3 to the power of 3, 27. Okay. So if I color one face, 9 of them will be colored. All of these will be colored. It will be -9. So, and then if I color this one, you see, these 3 have already been colored. So I will only color another 6. So all of these will be colored. If I color from this side, these are colored, it would be again minus by another 6. If I go and paint it from this angle, this one, okay, 2 columns have already been painted, this column and this column. So it will be only 3. Okay. If I color it from the top, only this one has not been colored. So it will be -1. If I go from the bottom, again, -1. So if you go on and minus it, it will be 27 minus 26, meaning that one of them cannot be colored. Which one? The one that is in the core. Okay, so that's the idea, right? So now you see 288 cubes without paint. So that means the cube must be much larger than 27, right? So the one that we could try next, let me change the color, is what if it's going to be 7 cubed? So we'll have 343. Okay. So if we go and color, but of course this will be 7 by 7, right? So let me clear this. Okay, we're going to have a 7 by 7 cube, right? It would be much larger. So here, because it's 7 by 7, there is 49 cubes here. So when we color it from one side, it will be 49. Okay. So if I go and color it from this side, it will be, this one will have already been covered by paint. So it will be -7 times 6, which is 42. So you see, if you minus it by 49, it would not create 288. If we paint 2 sides, it will be less than this. It would be, well, much less, 220 something. So that means this is wrong. There's no way to have a cube 7 by 7 by 7 that will be left with 288. So, well, not in luck, we have to go another one, 8 by 8 by 8. So what is 8 cubed? Okay, if you don't know, this would be 2 to the power of 3, again, 2 to the power of 3, which would be 2 to the power of 9. 2 to the power of 10 is 1024 divided by 2. If you don't know already, 512. Okay, so let's see. Let's minus it. First, we color this one. It would be 8 by 8, so -64. Then we go like this. It would be -8 times 7. And then we go and color this side. Again, only one of them have been colored, so -8 times 7. But look, if I go and color the fourth side, these 2 have already been colored, so it would be -6 times 8. And if you do the calculations, it will be 288. So what does the question want? How many faces have been colored? The first one, the second one, the third one, and the fourth one. So 4 faces have been colored. it's too difficult for question 23, or there's something I don't know, right? I'm not doing it well, but too long. But that's the answer, 4 faces. Okay, let's go and do question 24. Question 24 is rather easy. Well, this is going to be 1 over 4, right? So 1 minus 1 over 4 will be 3 over 4. Okay, so likewise, this is going to be 8 over 9 multiplied by 15 over 16. And we're going to go, let's just do another one, 24 over 25. And we're going to go all the way to 224 over 2 to 5. 2 to 5. Okay. So now let's see. Okay, the first term, okay, is just 3 over 4, so I'm going to write it here. Okay, the next one is when we multiply these two. Okay, this would be 3, this would be 2. So the next one is 2 over 3. Okay, so 2 over 3 multiplied by this would be 5, this would be 8. So it will be 5 over 8. Okay, this would be 3 over 5. Okay, so do you see a pattern? Well, and then it's going to go all the way to the last one. Okay, so is there a pattern that you see? Well, you can see it, but the problem is that these have been simplified. It actually is 4 over 6, which has been simplified. So I'm going to write, instead of 2 over 3, I'm going to write 4 over 6. Instead of this, I'm going to write 6/10, right? There you go. Now the pattern is apparent. Okay, these one are plussing by 1, plus 1, plus 1. These are being plussed by 2, okay? So what is the last one? It's a little tricky because still we could make a mistake. We have to be really careful, okay? So how many terms of this like this do we have? Okay, with the last one included, okay? See, the first one is 2, 3, the last one is 15. We're gonna have a total of 14 terms. So what we are looking for is 14th one, okay? So let's find the 14th. Okay, the starting number is 3 plus. Each time we're going 1, 1, 1. And how many jumps do we have? 13. Okay, 1 less than this. So it's going to be 3 plus 3 times 1. Okay, denominator starts with 4 plus. We're going to have 13 jumps like this. That's why we will go 13 times 2. So what's that going to be? It's going to be 16 over 30 simplified by 2, 8 over 15. So there you go. B is the right answer. Okay, let's go and do question 25 together. So for all of these shapes inside, the perimeter for all of them is 12. This one is 12, right? And the circle, small circle over here, this one is 12. Okay, and then we're going to go 1 centimeter away from all of these. It's going to be 1 centimeter, 1 centimeter, and 1 centimeter away. Now the question is, okay, which area, this area over here, the fishing area, which one is the maximum? Okay. We know that for a given perimeter, like 12, if they gave us 12 and they ask us to find out which shape will give the maximum area? It would be the circle. And which shape would give us the minimum area with 12 perimeter? You would try to go something like this. You would go with, for example, 5.99 here, and again 5.99 here, and you will have 0.01 and 0.01. You get the idea. We're trying to go close as much as possible to a line, right? To like a 6 and almost 6 line, because these are so close. This would minimize the area. Okay, but this is a different question, right? We need to check. Okay, so for this one, because I don't want to go and find the area for all of them, I'll make an easy example, right? So for all of them, to make them simple, right, I'm going to compare these two shapes. Okay, so the inside area will be 3 times 3. This would be 5. So this shape, the fishing area, would be almost 25 minus 9, 16. Okay, but of course, okay, we added these areas to all of them. But now let's go and come up with another example. Like, so let's make the shape another easy thing that we could quickly find the area of. Will be something like this: 5, 1, 5, 1. And then, okay, the outside shape will be again a triangle. Okay, this would be 3, and this would be 7. Okay, remember, you see, this area over here, both of them, we're adding the same area to all of them. So the comparison is absolutely accurate. So these little parts will be repeated over here. Okay, actually it would be from here to here. Okay. It will be repeated. But no, this is a small little thing. These small areas will be repeated in all of them. Okay. So, and now let's compare. Is the area changing? This one was 16. Now this one is 21 minus 5. Again, 16, right? So if you go even like, okay, I want to make it like 0.1, and you make this one 5.9, you still would see that, again, this would be 16. So suggesting that even though we are making different kinds of shapes with the perimeter, so all areas are the same. So for that reason, because it's the test after all, I would go quickly with option E without having to do all of this, because if I want to answer this question, I'll have no time for any other. In Australian rules football, a team scores 6 points for a goal and 1 point for a behind. During a game, V likes to record his team's score with a sequence of 6s and 1s. There are exactly 3 distinct sequences which give a final score of 7 points, namely 6 and 1, 1 and 6, and again all of them behinds, which would give 7. How many different sequences give a final score of 20 points? Okay, this one is, I think, rather easy. So what if all of these are behinds? Like to get a score of 20, we could have 1, 1, and all of them 1, and it will be just one possibility, like just one. Okay, we have, okay, one possibility of having this. Okay, the other one will be 1, 6, and 14 ones, right? And because the question says order is important, right? So 6 could be here, or 6 could be here, or 6 could be here. So because I said 14 ones and 1, 6, think about there are 15 spots. 15 spots like this. 6 could go anywhere. And the rest of them will be 1, 1, 1, 1, 1. Okay. So we're going to be, this will be 15 possibilities. The first match or the first score is 6, the rest are 1. The second 6, the rest are 1. We'll have 15 like this. Now, what if we have 2 6s? 12. How many ones do we need? 8. Right? So we need 8 ones, right? So what is the total number of numbers? 2, 6, and 8 ones? We'll have 10. So think about that you have 10 spots like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 6s could be anywhere. Maybe this one and this one. Right, this would be combination of 10 and 2. So we're going to have 10 factorials divided by 8 factorials and 2 factors here, which would be 10 times 9 divided by 2, 45 like this. Okay, so now what if, I'm gonna have to write it here. So what if we have 3 6s? And how many ones do we need to get a 20? 2 ones. So how many spots? 5. So how many? Okay, so we'll go 6s could be anywhere randomly. So combination of 5 and 3. This would be 5 factorials divided by 3 factorials and 2 factorials here. So it would be 5 times 4 divided by 2, 10. So let's add up everything. So now a 45, 10, 55, 70, and 71. Okay, let's go and do question 27 together. Okay, what is the smallest natural number n such that this number is a perfect square? Okay, so instead of this, I'm going to go and write x. Okay, so n would turn into, okay, x multiplied by x plus 2, okay, multiplied by x plus 6, and multiplied by x plus 8, and plus n. Okay, this is supposed to be square 4. Okay, if we go and multiply them, I'm not going to do it all here. Okay, so n will be, so I have it here, x to the 4th power plus 16 x cubed plus 76 x squared and plus 96x and plus n. Okay, so it's saying that this is supposed to be a perfect square. Okay, so that means n is supposed to be something to power of 2, obviously. Because the power here is 4, then the first term has to be x to the 2nd power, obviously, right? So, and then the other ones, because we don't know these, I'm gonna write ax plus b, right? How many x to the power of 1 and how many x to the power of 0 do we have? We don't know. Okay, so I will expand this, well, some of it at least. Okay, and we compare it with this, and then we find a and b. So, but I'm going to, no. So let me clean this to make it easier to understand. I'll just write this one more time because it would be easier to explain. Okay, So now, obviously, let's see. This one and this one multiplied, they will make, okay, x to the fourth power. Not very important because it's not giving away anything. But see, what terms will give x cubed? Okay, if I multiply this by this, it will give me x cubed. Okay, and again, of course, this one multiplied by this one will give me that. So these two will be ax cubed, okay? But we have two of this. It repeats, so it will be like this. So now we could compare these two together. This one and this one must be the same. For that reason, a will be 8. Good. Now let's go and find another one. I will change color. So I'm going to skip this one because it would be hard, right? To more difficult, and we don't need to go. Let's just see what terms multiplied will create 96 multiplied by x. It will be ax multiplied by b. And of course, it will be 2 times because, again, this ax will be multiplied by this b. Okay. So I'm going to write it here. It would be a b x, but it's repeating 2 times. Now let's go and compare this term with this 96. So AB will be, okay, 48. So B will be 6. Okay, so we got our A and B now. Okay, so let's go. N, so N will be like this. I'm going to rewrite it here. N will be x squared plus 8x plus 6 second power. Okay, now let's see this one. Okay, this last term is just a number with no x. Okay, when we multiply these two, okay, they all have x's. The only term that doesn't have x is this 6 squared. Okay, so this n will be 6 squared equals n. So n will be 36. If any of this was like when we were expanding it, I was unclear, you just have to expand it yourself. You'll see. It will take more time. And then you will understand what I say. Like, why is this 6 squared? Just expand it. The only one term that creates a number without a value of x, without a variable x, will be 6 times 6, 36. Okay, let's go and do question 28 together. I have a large supply of matchsticks in 4 colors, red, yellow, blue, and green. I use them to make squares where each side is 1 matchstick long. I count 2 squares as the same if one can be rotated or reflected to match the shape or color of the other one. How many different squares can be created? Okay, so it means, for example, if I have a square like this, so, and then, so these 2 squares, are they 1 square or 2 different squares? Are we going to count them as 2 or 1? The answer is 1. Why? Because if I rotate this clockwise 90 degrees, I'm going to get this, so it will be 1 square. Okay, knowing this, with this in mind, let's go and actually see all of the possibilities. Okay, now what if all the 4 are the same color? for example, blue, blue, blue. Okay, and we could go on and write, of course, red, 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 or yellow, yellow, yellow. So from here, 4 and 0, I'm going to write like this. We have 4 possibilities like this. All blue, all yellow, all green, all red. Okay. So the next one is 3 of the same color, 1 of a different color. So for example, blue, 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 and then a different color. So how many possibilities like this do we have? To choose the first color, we have 4 possibilities. To choose the next color, we have 3. So it would be 4 times 3. Okay, for 3 and 1. What if we have 2 and 2? Say 2 of them are the same color. For example, for this one, we're going to have blue and blue and red and red. Okay. So let's see, when it's like this, okay, when blue and blue are facing and a different color also facing, think about it like this. You have 4 colors, you want to just pick 2, okay? Maybe blue and red, maybe blue and yellow, and then you put them like this. So it will be, for this one, it will be combination of 4 and 2, which will be 6. But 2 and 2 is not over. Why? Because what if I write them like this? Blue and blue like this, and red like this. Again, the same reasoning. We have 4 colors, we just want to pick 2 from them. So it will be combination of 4 and 2, which would be another 6. So far we have a 4, a 12, a 6, and a 6. Okay, so now the next one will be, how about 1 and 3? 1 and 3, we have already accounted for that here. So it will be nothing new. So 0 for this one. Okay, it will be 0. Okay, now the last one is, what if we have 2? Okay, 1 and 1. Okay, what's that going to be? So for example, we're going to have red and red, and then we'll have 2 different colors. So how many possibilities for this? For to choose the red one, we have the ones that are facing, 4 possibilities. Okay, and then from the remaining 3 colors, we'll have 2. We have to choose 2. It will be something like this. So it will be 12. But this is not over 2, 1, and 1, because what if the 2 reds are like this? See, red and red. And then we have a yellow and we have a green. See, I made this with the same color as this one, but the 2 reds are no longer facing. But the number of possibilities is again 12 with the same reasoning, right? To choose the red one, you have 4 options. To choose the next 2 colors, you'll have 3. Again, we'll make 12. So now the only one that we didn't count for is, what if all of them are the same, different colors? So what would that be? You see, I will think about it like this. We have red. All of them are supposed to have red, right? How are they different? What if one case in front of red is green? In front of red could be yellow. In front of red could be blue. Okay. And then blue here, blue here. Okay. Yellow and yellow. Green and green. Okay, these are the only, no, green. Okay, so these are the only 3 that we could make. Okay, with all the colors being different. If you can make something like else, If you rotate it, it would be one of these. So let's add all of them. Basically, we had a 4 plus 4 12s, 48, plus a 3, 55 is the answer. Okay, let's do question 9. Question 9, we're dividing this number by first 1. What is the remainder? 0, we write it here. 499, dividing it by 2, the remainder will be 1, we write it here. Okay, and we do it all the way to 499. And then we add all of them together. This sum will be called what we call M. Okay. We do the same thing for 500. We divide it by 1, divisible 0. By 2, divisible 0. 500 divided by 3 will have remainder 2. We add all of them. Okay, we will call this N. The question says, what is the difference between the numbers M and N? Okay, so we divide 499 by these numbers, right? 4, 5, 6. If we divide it by 7, 499, the remainder will be 2. Okay. We would love to divide it by 8. Okay. It would be 480 is divisible plus 6. So 3 will be left. Okay. If we divide 500 by these numbers, okay, we'll get 3 and we get 4. Is there a pattern? Not really. But the question is looking for M minus N. Is there a pattern for that? So it would be 0 minus 0. I'm going to subtract these two numbers. 0 minus 0 will be 0. I'm doing this for M minus N. 1 minus 0, 1. 1 minus 2, negative 1. So far, there seems to be no pattern. 4. Is there a pattern so far? Not really. Okay, 2 minus 3, negative 1. 3 minus 4, negative 1. And if you do that for 9, it would again be negative 1. So we see negative 1 is repeating so often, okay? And think about it. It's supposed to happen, right? Imagine we have two numbers, okay? And we want to divide them by any number. But this number is not divisible by any of them, right? See, I can't write 10, 5, 2, no. But if I write 7, okay, what would be the remainder of these? This will be 4. This would be 3. And this is always true. This one is 1 larger because the number is 1 larger. So the remainder will be larger if none of them are divisible. So we could expect this negative 1 to repeat. When doesn't it repeat? Well, when 499 or 500 is divisible by a number. So we know that 499 is a prime number. So easy peasy, right? It will not be divisible by any number. Just 1 on 499. Okay, but 500, okay, is divisible by a lot of numbers. So we just have to find those, okay? So 500 is divisible by 1, 2, 4, 5, okay, 10, 20, 25, 50, 100, 125, 250, and itself 500. Okay, so for these numbers, we will have something unique. Okay, but for the rest of the numbers, all negative 1. So you see negative 1 will repeat. But you see for this one, because for 1, both of them became 0. Okay, so for 2, we got 1. We didn't get -1. For 3, we get -1, but for 4, we don't get -1, we get 3. So all we have to do is find these numbers. So, okay, for 1, we got a 0. Okay, plus 1. For 4, we got a 3. For 5, okay, we got a 4. Okay, and now for 10, all right, we have to check for 10. What is the remainder of 499 when we divide it by 10? It will be 9. When we divide it by 20, it would be 19. You see, there's also a pattern. When we divide it by 25, 24. When we divide it by 50, 49. 499, when we divide it by 100, the remainder is 99. Okay, 124 plus 249. Okay, but this one, 499, that's the last number. Okay, so because 499, I will not be divided by 500. So these are the positive numbers. Okay, so but how many negative numbers do we have? Okay, so we had 499 numbers. Okay, and from these 499 numbers, okay, we had 1, 2, 3, 4, 5. You could count it: 6, 7, 8, 9, 10, 11. 11 of them are not -1. The rest are -1. So minus this, we're gonna get 4, 8, 8. So we're gonna have 488 negative ones, and with these positives. So all we have to do is add them and minus these numbers. Let me see if I have it here, or we just need to do it. I have it. So let's just go and add all of these together. So okay, it's gonna be, I'm gonna add like this: 250, 100, 375 minus 2. Okay, plus 100, 475, 525, 550, 570, 580. Okay, 580, 584, 87, 88. So it's going to be 588. But I didn't count. I rounded the numbers. Okay. It's going to be 1, 2, 3, 4, 5, 6, 7. I think I rounded by 7. Okay. So when we add these, it's going to be 581 minus 488 negative ones. Okay. So what would be the answer? Okay, it would be 3. Okay, 9. So the answer to all of these questions will be 93. Okay, let's do the last question. We know that the number of blue tiles over here inside is supposed to be 4 times of the red ones. Okay. And then after finding the values for the number of reds, number of blues, we're going to break them and make 2 new rectangles, but they don't have to be the same size. Important. Okay. Now let's go. Let's start by easy examples. Okay. So for example, what if we have only 1 blue? So how many red do we need? I have to make this red. How many red do we need? Okay, we need a lot of reds. So you could see here that we would need 8 reds for 1 blue. But as the number of blues grows, okay, so this ratio becomes smaller. So now let me go and draw something larger. For example, what if we have 6 blues like this? So how many reds do we need? Okay. So we need 2 reds here, 2 reds here. So 2 times 2 of those 2s. And 2 of these 3s, 3 here and 3 here. So how many more do we need? 1, 2, 3, 4 for the corners. Okay, now we could turn this into a formula. Okay, so now we have 2 over here, right? So this is 2. This was 3. Okay, this one, instead of 2, let's call this one, for example, n. Okay, instead of 2, oops. Instead of 2, we're going to have n. Okay. And instead of this 3, we're going to have n plus 1, 2, or any numbers. So here I will call it n plus k. So right now, how do we find the number of blues? Multiplying 2 by 3, right? So the number of blues will be n plus n times n plus k. Okay. Now, how about the number of reds? Okay, it would be this n, right? This, which would be this 2, plus this 3, which would be plus n plus k. And we're going to have 2 of these plus 4 for the corners. So let's go and write the formula. So it would be n plus n plus k. Okay. Because we have 2 of these sides, I'm going to multiply them by 2 and 4 for the corners. Okay, this would be the number of red. And now the question says the number of blue, okay, divided by the number of red will be 4. Okay, so if you go and simplify this, it will give you a quadratic equation that you could go on and solve, right? So what I have done, if you put here, instead of k, you put 1 here, you will have no integer, so it doesn't work. But if you put k equals 2, you will get n16. So it works for this number. This is so far I have done. So for this triangle, it will work. So if we have 16 times, so for this one, if we have a triangle like this one 16, this one 18, this one works. So this would be the blue one. If we multiply 18 by 16, we're going to get 288. Okay. So if it was in the test and I wanted to answer it quickly, I would just leave it at this here. But can we break this 288? Okay. And can we make 2 rectangles of different sizes? Well, I haven't checked. So you could go on and try different values for k and find different values for n if possible and see which one works. So if it wasn't a test, I would just go with this. We have 288 blues and 72 reds. It works, okay? So I'm going to leave it at this place. So if you have more information on question 30 or any of the other questions, please leave it in the comments and I'll see you in other videos.